TK the Science Guy.
TK the Science Guy.
TK the Science Guy.
Apes rule.
TK the Science Guy.
Wind power. I'm a big fan. Time. TK the Science Guy.
TK the Science Guy.
Oh, hey there, CW Bio. Mr. Kennedy here with yet another really cool lab experiment for us to do together. Today, I've got all kinds of stuff. Beakers, I've got jars of sand, I got this stuff. I don't even know what this is. And we're gonna use this to do an experiment called modeling index fossils. So, here's what I want you to do. I want you to go to Mr. Kennedy's class webpage. I want you to find this handout. Yeah, that one. That one called Modeling Index Fossils. Yeah, get yourself a copy of that, meet me back here, and let's do an experiment. I'll see you in a minute. Hey, welcome back, guys. I hope you had plenty of time to go to our class webpage and get yourself a copy of the handout titled Modeling Index Fossils. So here's what's gonna happen. I'm going to do this experiment with you, not for you, and then you're going to use what you see and hear to generate your lab report, answering all the questions that you see in your handout in your notebook. So that's the deal. You gotta pay very close attention to what you see and what you hear so you know what to put down on your paper, right? So use your powers of observation and join me as we go through this. So the whole idea of modeling index fossils, well, the point here is to use a fossil to determine the relative ages of rock formation. So that's what this is all about. Now, I can't go dig up fossils. I mean, you know, I don't know where they are all the time. So, like, we're gonna have to do a modeling activity to kind of figure out, like, how scientists figure out how old things are by their position in rocks. So, I've got some bottles of sand here. I've got some beakers with papers in them, and we're gonna label these beakers A, B, and you guessed it, C, okay? And then I've got kind of this mat, this big mat that I'm gonna set everything out on, and then I've got these leaves. Woo, okay? Just gonna leave that right there. Get it? Leaves, leave it, right? Okay, so anyways, what you need to do so that you can participate is start off by answering your pre-lab questions. There's some pre-lab questions right here. Make sure you answer those. Then, and you know, next, I want you to create in your notebook these pictures that you see here. You're gonna label the layers and a data table just like this one, and we're gonna fill it in together. So, get to work, get that stuff down in your notebook, and meet me back here. Welcome back, everybody. I hope you've had ample time to get everything all set up. If you've been reading through your procedures, step one on our data tables is for us to pick a start time, a time that we want to use like a literal time on the clock as the starting point for our experiment, our model, okay? So what time is it? Game time? No, modeling index fossil time. So hey, once you've picked a start time, for me, I'm gonna pick, I don't know, 1 p.m. and I'm gonna write that on my paper, 1 p.m. Then it says, right, once you've created a start time, choose a starting time, few minutes from now, and write the time in column 1. Then list times at 3-minute intervals for the next 30 minutes going down your data table, right? That's gonna be important because that's how I'm gonna set up when I'm gonna like add things to my beakers as I model rock layer formation and put fossils in those rock layers. So I'm gonna take a minute, fill in my data table, and then show you what I got. All right, ladies and gents, this is my data table. Like I said, I started at 1 o'clock and I've used 3-minute intervals to separate those time periods, and now I'm at 1:30 with my stop. So your data table should look similar to mine. The next thing that you're supposed to do is to go over here where it says years ago in millions. 30 minutes of time in our world is going to be, well, analogous to millions of years, 30 million years to be exact. So what we're gonna do is we're gonna take next to start in years ago, and we're gonna write the number 30 for 30 million years ago right there. And then we're gonna subtract 3 from that and fill in our column until we get to the stop. All right, so you go to work and then we'll meet back here in just a second. Well, here's my data table, ladies and gents. Does yours look like mine? Isn't it kind of weird that we started at 30 here and now we're gonna end at 0 down there? What you need to think about in terms of this activity is that these time periods over here that advance forward in our time are doing the same thing over here. Remember, 30 minutes is supposed to be 30 million years. So we're gonna start at 1 p.m., which in theory, in this model, is 30 million years ago. And when we stop, right, at 1:30, moving forward, that's supposed to be present day. Now, I've got a sequence of events that I need to follow if you're reading along with me in the procedures, and you're gonna be able to watch me add sand to beakers in a specific order at specific time periods that are labeled over here on the side. So I'm literally gonna have to watch the clock and wait 3 minutes and then do something, like adding sand to certain beakers. And then once I do that, right, we'll kind of have an idea of how these things form up here at the top. Okay, gang, hopefully you're all set and you kind of understand how this data table works. The idea here again is that I gotta have somebody keep time for me. I'm doing this by myself, so this is gonna be a little bit of a challenge. Hopefully I don't get lost or confused. But what I'm going to do is I'm gonna start at 1 p.m. and then I'm gonna wait specific time intervals that I have on my data table. And as I wait like 3 minutes, you know, from 1 p.m. to 1:03, I guess I'm gonna sit here and watch the paint dry on the walls. But once I get to 1:03, like following the procedures in here, I'm gonna have to add sand to my beakers. Now, I've got my beakers labeled with pieces of paper. So there's an A, there's a B, and there's a C beaker. And I'm gonna put them out on this little mat that we have here, okay? And the mat is supposed to represent the world, okay? That's what it's supposed to represent, or basically the earth, all right? And I've got these leaves that I'm gonna set aside until just the right time according to the schedule, like when they're supposed to show up. Like if you look really close, see, there's some stuff here that says like leaves appear and leaves die out. Like that's when I'm gonna use my leaves, okay? But before I can get to leaves appear and leaves die out, I gotta follow these steps and add sand, you know, to these beakers in a specific sequence every 3 minutes. It's gonna be confusing. It's gonna be crazy. So help me out, right? Help me figure this out. Are you ready to start? All right, there's no turning back now. I'm looking at the clock, I'm looking at the procedures, and it's telling me, well, it's now time to put 2 centimeters of sand in beaker C. So here we go, right? Hopefully I don't mess this up. Okay, so 2 centimeters of sand, beaker C, right? All right, there's, yeah, that looks good, okay? 2 centimeters of sand, beaker C. So we guess we gotta sit here and wait. Oh, what? What? Oh, is it time for the second round already? My goodness, I was asleep. Okay, so what am I supposed to do at the next time period? I got 2 centimeters of sand in beaker C. Now it says add 2 centimeters of salt to beaker C. Wow. All right, so what are we gonna use for salt? Well, I'm gonna use this stuff. Whoa, this is vermiculite. All right, because, you know, I want to make sure that I get some good use out of the soils that I have in my classroom. So, oh, I'm making a huge mess because somebody punched a hole in the bag. That's just fantastic. Let's go to the other side. Okay, other side, 2 centimeters of vermiculite. Whoa, that's a lot of vermiculite, Mr. Kennedy. Okay, so, that's way more than 2 centimeters. Let's balance this out a little bit. Okay, there we go. All right, so if you look close, I got a layer of sand, and then I got a layer of vermiculite. So, according to the experiment, which is now covered in a mess on my table, this layering of sand and vermiculite, or salt, is supposed to represent layers of rock. What's up with beaker A and beaker B? Well, I don't have to do anything with those yet. I'll see you in 3 minutes. Time for another nap. Oh, we're back. Okay, so it's our next time interval, and now I'm supposed to add a layer of sand to both beaker A and beaker C. So back to beaker C here. Okay, so some more sand. Alright, we get some sand in here. Yep, we'll just kind of level that off. And beaker A is supposed to get some sand. So here we go. Yeah, that looks pretty good. Nah, we can all right. There we go. All right, so we got some sand in A, and we got 3 layers of stuff in C. That's pretty neat. Okay, time for nappy night-night. See you in 3 minutes. Well, good morning, CW Bio. Yep, it's been 3 minutes, and on this step, it says I'm supposed to add some of this vermiculite stuff to both beakers A and C. You know, poor little beaker B hasn't even gotten into the mix yet. I don't know. So here we go. Beaker A is gonna get 2 centimeters. Let's find that hole again. Void that hole. All right, now we're gonna get 2 centimeters. Whoop, there we go. Smooth that out. There, that's good. 2 centimeters. Okay, ish. All right, and same thing here for beaker C. Whoa. All right, we'll smooth that out. All right, see all the layers? Pretty cool. And now I get 3 more minutes of nappy night-night time. See you in a few. Been 3 minutes. Time for a little bit more sand. Okay, so here's beaker C, and here is beaker A, and we're gonna put a little more sand in here. Right, remember, each of these layers I put down is supposed to represent rock formation, okay? So, go for C. Don't want to shake it up too much because we don't want our layers to blend into each other. See how we can see layers? Right? Layer, 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 layer. That's what we want. We want to see those layers. All right. 3 more minutes. But hey, when this event occurs, this next 3 minutes, look at the schedule. What? Something special is going to happen. I hope you're ready for it. So ladies and gents, are you ready for this? This is the time period in our Earth's history where leaves appear, green plants, okay? So I'm gonna put some leaves out here on this little mat that's supposed to represent the Earth because I'm modeling the formation or the appearance of leaves, right? So at this time, at the correct time, now I'm gonna add a layer of salt or vermiculite again to beakers A, B, and C. As I add it, I'm gonna put a leaf in each one. So, C finally gets a leaf, right? We're gonna put a leaf right here, okay? And A is gonna get a leaf. We're gonna put a leaf right there, and we're gonna leaf it alone. Oh boy, yeah. And then beaker B, okay? Beaker B is also gonna get a leaf, right? And we'll just leaf it right there. Okay, and we're gonna add a layer of salt to each of these beakers. So here we go. All right. There. Put a little vermiculite in this guy. Okay. Whoa, almost dropped. Okay, there it is. We got that one. And a little vermiculite in this guy. Remember, vermiculite's gonna be our salt. Oh, way to go, Mr. Kennedy. You just dumped it on the table. All right, there we go. And this one. Okay, same idea. You guys having fun yet? I know I'm having fun. I'm making a mess. That's what I'm doing. I'll tell you that right now. Okay, there we go. 3 more minutes. Meet you back here. You guessed it. It's been 3 minutes. And, well, unfortunately, leaves died out on Earth. So we got to take them off of our little mat and get rid of them. And at this point, we need to add some sand to a couple more of our beakers. So we're gonna leave beaker C alone for now. Okay, there's the leaf in beaker C. And we're gonna add sand, right, to beaker A, which is right here. Okay, beaker A. And we're gonna add some sand to beaker B. Okay, so here goes my sand. Alright, trying to leave that pocket there so you can see the leaf in that layer. There's that pocket. Okay. This poor little leaf is just absolutely buried down here. Let me try to help him out so you can see him a little bit. Okay. Because we definitely want to know where that leaf is. Alright. And we'll put some sand on top of this guy. Okay, so hopefully you get the idea. We're just gonna keep adding sand and salt to these guys every 3 minutes. Okay, we've gone through the exciting leaf appearance and leaves dying out. So I'll just fast forward to the end here, and we'll take a look at the final product. Okay, give me a few more minutes, and I'll show you what we've made. Are you ready for the big reveal, ladies and gents? It's been 30 minutes, or according to our activity, 30 million years. There you go. All right, here is beaker A. Dun, dun, dun. Check out those layers. Look where that fossil is in there, or excuse me, the leaf, right? And here is beaker B. Dun, dun, dun. Right, look at those layers, look close, you can see those layers there in the side and where the fossilized leaf is. And beaker C, all right, here we go. Beaker C, this one we've been working on since the beginning. Look at those layers, yeah, look close, check them out, very cool. Now, your job is to, okay, record your data for this experiment from those beakers that I just showed you. So you've got the timeline all filled out. I showed you that already. I want you to recreate the drawings that you're seeing in the beakers here and on your paper. And I want you to give me like accurate time frames for when these leaves showed up in each of these beakers. Now, the interesting thing about this, if you think about it, right? Looking at your data table, you should be able to see that right about 1:15 is when leaves showed up on our data table. So if it's 1:15, I'm thinking that's about 15 million years ago. So how do index fossils work? Well, if you look at this beaker where the leaf is here, and you look at this beaker over here with the leaf right there, and you look at this beaker, right, with the leaf way down there, okay? The idea is that as you see all these different layers of rock, okay, if leaves showed up 15 million years ago, well, wherever that leaf is, that's 15 million years ago. That's how it works. So this sets the benchmark for aging or dating the other layers. So using that, I want you in your drawings of these beakers that are just like the ones on the handout to determine the age of each of your rock layers. Remember, in theory, each layer is separated by 3 million years. So you should be able to do the math knowing that right there is 15 million years ago. Okay, ladies and gents, that's how you calculate your data. Once that's done, don't forget, there's some analysis questions. It wouldn't be a lab if there weren't analysis questions. So, interpret your data, answer your analysis questions, and I hope you learned tons about index fossils. I know I enjoyed this. I hope you did too. I'm Mr. Kennedy, and I'll see you next time.
TK the Science Guy.
TK the Science Guy.
TK the Science Guy.
Apes rule.
TK the Science Guy.
Wind power. I'm a big fan. TK the Science Guy.
TK the Science Guy.